Okay, in this video in section 13.5, we're going to look at question number 3 on the worksheet. And here we're given a function z equals f of xy, where x is g of t and y is h of t. And our job is to use this table below to compute the derivative of z with respect to t when t is equal to 1. Okay, so I'll go ahead and just start out by writing our chain rule diagram here, usual setup. So z depends on x and y depend on t, and so then we were looking right at these intermediate rates, so del z, del x, and dx dt, and then del z, del y, and dy dt. Okay, so if I want to write out dz dt, right? Usual thing here, so I can say that dz dt is equal to the product of the blue rates, del z del x, dx dt, plus del z del y, dy dt. Okay. So what I'd like to do now, right, is use this info in our table to go ahead and figure out what the value of this derivative dz dt is going to equal when t is 1. Okay, so off here to the side, I'm going to make a little comment here. Okay, so when t is equal to 1, okay, well, what could I say about x and y? Well, for that, notice, right, x is g of t and y is h of t. So I could say that, well, x would just be g of 1, and g of 1 is given in the table to be 3. Okay, and y, that would be h of 1, and I'm also given that value in the table. That's equal to 10. Okay, so in other words, when t is 1, right, in terms of our coordinates for x and y, we're located at the point 3, 10. Okay, so that's one comment here to make. The other thing just is in terms of the notation. Notice here I'm given the partial derivatives of the function f, right, in subscript notation, right? So what are those referencing? So like fx, right, that's really the same thing as just del z, del x. So this is really our fx. And for emphasis, I'm going to write this as it's fx, right, as a function of x and y. Okay, dx dt, what's that? Well, since x is g of t, dx dt would just simply be g prime of t. So for this part, that's just going to be g prime of t. And then we're adding to that del z del y, which likewise would be f sub y, the y derivative of our function f, again is a function of x and y, and then I'm going to multiply that with dy dt, and that would just be our h prime of t. Okay, cool. So this right here is our dz dt. And so now, right, what I can do is just simply plug in 1 for t. So that's going to go in for the g prime and the h prime. But then also from what I just said here, right, as far as x and y are concerned, we're just going to evaluate these partial derivatives of f at the point 310 and see we're given all of that necessary info in our table. Okay, so let's go ahead and execute that. So we got dz dt evaluated at t is equal to 1. So this is going to be f sub x at 3, 10 times g prime of 1. And then I'm going to add to that fy at the point 310 times h prime of 1. All right, cool. So now let's just plug in all the given info. We got 100 for the fx derivative times g prime of 1, which is 4. And then we're going to do plus, that'd be minus 50 for the y partial derivative times h prime of 1, which is 3. And so what do we got here? This is 400 minus 150. So that's going to equal 250. All right, great. That is going to do it.